Okay, so good afternoon and welcome everyone. Thank you for joining this session today. My name is Bertrand Cass. I'm Business Development Manager at Sestel. For those who don't know us, Sestel is a Spanish company dedicated to mission-critical communication system with over 25 years of experience supporting public safety, security, and defense sectors. Today's webinar looks at the transition from legacy to next generation eCall, what is changing, what means for PSAP, and most importantly, how to effectively prepare for the technical impact using dedicated tool to anticipate and validate this evolution. To guide through all of this, I'm very pleased to introduce Max Godoy, one of the key experts behind the development and deployment of the eCall solution at Sestel. Max has led numerous projects across Europe and brings deep technical knowledge and insight in both legacy and NG112 architecture. He's also participate as a Sestel team, all the people that take part of the standardization events such as the plug test. So just before we start, a few quick notes. If you have any questions during the sessions, so feel free to use the chat at any time. So we'll go through your questions at the end of the presentation. Also, the live subtitles are available. Just click on the More button, the three dots at the bottom of the Zoom, in the Zoom toolbar, and select Show Subtitle. So with that, without not expecting more, let's start. Max, the floor is yours.
Hello, everybody. Thank you for coming to this webinar. I think I'm not getting my background. Thank you for attending this webinar. We are going to cover different aspects, and I'll start the presentation here. There you go. As Bertrand said, I'm the product manager for eCall solutions at Sestel. So I've deployed quite a few eCalls in this last few years, and now we are again going for the next generation of eCalls. I'm going to follow this talking points. First, as an introduction, we're going to see how we get from legacy eCall to next generation eCall, the different characteristics of each one, benefits and shortcomings of each one. Then we will see what the impact on PSAPs infrastructures this step to and next generation eCall will have on PSAPs. Then a short reminder of the upcoming standards or regulations and when they are going to be enforced. And then we'll see a list of the solutions that Sestel has to ensure a smooth transition for the next generation eCall, and we'll go into a question and answers phase. Okay, legacy eCall versus next generation eCall. As a quick introduction, because I suppose everybody here knows what the eCall means, and especially the legacy eCall that has been in operation since 2018. Well, eCall is a service that relies basically on three elements. The first element is as a device on the vehicle, on every car in Europe, called the in-vehicle system, or IVS for shorthand. That IVS is dormant inside the car, but when you have an accident or when you press the button for the eCall that's located on every car registered in Europe since 2018. This IVS will make an emergency call, therefore a call to a 112 PSAP, indicating that is an eCall call. What that means, it's going to establish a voice call, a normal voice call, but over that voice call, it will send information about the car and the incident. That information, which is contained in an element called the minimum set of data, the MSD, has a few enough information for the PSAP to react to that emergency information, like the car type, the VIN number of the car, the position of the car, the number of passengers in the car, the type of fuel that the car uses, and so on. But essentially, this legacy makes a call through the phone network, through the circuit switch phone network, that is GSM, 2G, 3G phone network, and sends that information in band, meaning that it uses an encoding method very common to modems to send the information as sound. That means that while it's sending the MSD in band as sound, there's no voice coming from the car or from the operator, and the system has to wait for the MSD to be transferred in band before the voice can be connected between the car, the accident car, and the PSAP operator. That in-band modulation that we mentioned has a problem that it depends a lot on the quality of the voice channel. Sometimes there's not very good coverage. Sometimes there's lots of noise in the communication, and the MSD takes a long time to be sent and received, and even in some cases it cannot be transferred because of this noise on the line, and the transfer of the MSD is cancelled after 20 seconds of trying. Here we have two real case extracted from real case scenarios in which we have a good transmission that takes under 4 seconds to send all the data, which means for those 4 seconds, the PSAP operator cannot hear what's happening inside the car, and the people on the car cannot speak to the PSAP operator. And then a bad case in which it takes all of 20 seconds to try and transfer and fails to transfer the information. That means that during 20 seconds, the first 20 seconds after the accident, there's no communication between the car and the PSAP operator. That's the main drawback of legacy eCall. What's the solution to that, or what's the proposed solution? Next generation eCall. What happens in next generation eCall? In next generation eCall, we don't use a voice anymore. We use signaling. We use signaling to transfer that information. The MSD is piggybacked into the signaling channel. Nowadays, new networks for telephony are being deployed. The IMS network is being deployed, and this IMS network is IP-based. Therefore, we use or communications, mobile devices as a communication will be using the SIP protocol to communicate from the car, the IVS on the car, to okay. It seems not everybody is seeing my slides, so I'm going to reshare them. Just a second. Now, is everybody seeing the slides? Okay, it seems now it's okay. So as I was saying, next generation eCall is based on next generation networks, the IMS network, essentially for phone communication. This IMS network, an IP network that is a packet switch network, now uses SIP as the signaling protocol to establish calls, and the next generation eCall will take advantage of this SIP protocol and this packet switched network by using the signaling part of the call to send the MSD in digital format and not as a voice element in the channel. The solution diagram is, as you see, again a car with an IVS. This time the call is voice over LTE on a 4G 5G network that goes through the IMS that is painted here in orange. What you have here in blue, the ESINet is optional. It's a network for PSAPs that is describing the next generation 112 specification, but it's not mandatory, at least not for the moment. And then we have on the right the PSAP that will be receiving this call all through this SIP signaling method. Okay. The invite on the right side, we have an example of the dialogue using the SIP protocol. It's a very bare bones example in which the invite of the SIP protocol carries the MSD inside it, and when the eCall PSAP receives that information, it acknowledges that it has received correctly the MSD data, both on the invite and the OK elements of the SIP dialogue. Therefore, there's no extra time involved in that transfer. Here we have a few of these features. For the NGeCall, the call is equivalent to any other emergency call on the NG112 network or in the next generation network, if you want to call it that way. Voice over LTE and SIP protocols are used on the IMS network, as we saw, and they are also being used on the PSAP. These protocols and SIP protocols, they have a way of signaling emergencies using URNs. This is a technical detail. URNs indicate services and not endpoints on the network. And so it's the network that will decide what the endpoint is. The endpoint being the PSAP that actually receives the call, the NGeCall communication. The URNs that are already registered for eCall, for next generation eCall, are described here: service source eCall manual, service source eCall automatic, service test eCall. All these URNs are very similar to the signaling used in 2G for eCalls, for legacy eCalls. So the working, the service is essentially the same, only the technology used is more modern, quicker, and less failure prone. Then again, the MSD, that is the minimum set of data, the information that is being sent from the car, there's been a slight modification. MSD version 3 has been adopted. On legacy call, we had MSD version 2. Version 1 was never used. Version 3 basically has the same information as version 2, only some of the information that was optional in version 2 now is mandatory, like location deltas. But essentially the information being conveyed is the same. The only thing is that since it's a different version of MSD, it requires a different decoder. So even though the information is similar, the software used to decode it is different, and that should be taken into account. Advantages of next generation eCall, as we saw, that using the MSD encoded in the SIP message means that there's no audio modulation to begin with for the MSD transfer. So it's easier to transfer. It's it being part of the initiation of the dialogue. It is received. There's a guarantee of the MSD being received, or else the whole dialogue wouldn't be received. The voice between the vehicle, between the car and the PSAP is immediate because there's no extra time for the transfer of the MSD. The MSD resend request, which is done again by protocol inside by a function inside the SIP protocol, is transparent to the voice. There's no pause to resend an MSD. It's instantaneous and out of band, no interruption. And the MSD, the original MSD, because of the time it took to be transferred on a voice channel, in-band channel, was limited to 140 octets. Nowadays, by using it as a part of the SIP invite payload, it can be expanded beyond 140 octets. There will be no size constraints. Here we have we indicate that it's an NG112 call, that with all the advantages of the IMS. It means that there are additional elements for routing to the PSAP. Traditional routing is done by location of the originating call, usually by the location of the BTS of the antenna to which the device, the IVS, was registered on the mobile network. Nowadays, we can have additional data like, again, the location of the antenna, but also location included on the SIP invite and in bid flow format, for instance, or even some devices that can use the information, the location contained in the MSD. So there are additional elements that can help the routing to the PSAP. And the future possibility of transmitting other media in the future, since let's not forget that SIP is a protocol, is a signaling protocol that allows the transfer of voice, media, and text, mostly for next generation 112 systems. So it's perfectly conceivable that video and text could be included in future versions of eCall. We have here a simple example of call routing. In this case, the call routing is done, as I mentioned before, by 3 different properties. On the invite we have here, there's a indication of where the call comes from. That would be the cell, the tower, or the antenna, if you wish, where the call was originated. So the network, the IMS network, or the ESI network, if an NG112 network is used, can use that information to route the call to the most appropriate PSAP. The second possibility is that a PIDF low is included inside the SIP invite, usually inserted by the IVS itself. And the elements in between can use that information to also choose the most appropriate PSAP and route the call there. And then there's the third possibility, as I said, that the ESI net could read the contents of the MSD, that is, decode the MSD, disassemble it, look at the location that the IVS is reporting from its GPS on board, and use that to route to the most appropriate PSAP. Again, as I said before, MSD version 3 is standardized in the standard 15722. There's a 2020 version that describes the version MSD version 3. The most notable differences with version 2 is the inclusion of recent locations. The 2 Delta locations that were optional in version 2 and that are now mandatory in version 3. The number of vehicle categories has been expanded. There were a few vehicle categories. I think there were 9, and now there are something like 20 different categories. It now covers the full UNIS categorization. And then there's a few quirks like the field called number of passengers has been replaced by number of occupants, because there was there were some misunderstandings on whether the passengers did include or not the driver. But as I said before, essentially the information is basically the same. There's only a clarification on some of these. And then there's another item, which is the additional data. The MSD, both version 2 and version 3, have a field to include additional data. Up to now, that additional data has been open to the manufacturer to give an interpretation of what that additional data is. And recently, Euro NCAP has standardized one type of additional data that defines information about a car impact. It is not mandatory, but if the IVS on the car sends it, then the PSAP might be required to decode it. There are other possible additional data, but this is the only one that has been standardized up to now. Now let's go and see what the impact of this new NGeCall migration has for PSAPs. This is the diagram that we saw before for NGeCall, and in this diagram I've outlined in red both the position of the PSAP here on the right and the SIP dialog between the IVS and the PSAP. Okay, this is what the PSAP really has to worry about. The PSAP has no way of controlling what happens on the IMS or on the ESI net if an NG112 network is included in the setup. What we've seen, as I said, the IMS network and the MNOs take care of the IMS network. The MNOs, the mobile network operators, define the workings of their IMS network. DSINet and NG112 is an element that is optional and that can provide further methods of routing the calls, both NGeCall and voice calls or video calls or text calls to different PSAPs. NG112 refers to all those media. NGeCall is just one of them, and the ESINet is a refinement in the sense of providing better routing mechanisms for all those other medias or needs from the person that is on the making the call to the emergency system. And let's concentrate on the PSAP infrastructure. I'm going to show you different setups on PSAPs that we've seen or that we foresee in the future to implement NGeCall. This one here is the basic setup we've found on many PSAPs migrating from circuit switch network, basically an ISDN network, into a next generation network that is a network based on packet switching and SIP signaling as their method. What happens is that they usually keep their PRI, their ISDN PRI, into their PBX because either the PBX is old and does not support SIP, or they don't want to change the technology because of money constraints or other technological constraints. For instance, we've seen in many cases that the recording technology that they have records PRIs, but does not allow the recording of SIP-based communications. So they keep the PRI and they insert a media gateway here, and all the voice calls come through the next generation network through an SBC on SIP to the media gateway that transforms that to a PRI, and the rest of the system works as usual. Problem for us in next generation eCall, that SIP call incoming here has the MSD as part of the SIP communication. When that SIP communication is turned into a PRI communication, every header except for the originating number, the destination number, and the voice, everything else is lost, including the MSD. Therefore, if you have a setup like this, you cannot use an eCall device, an eCall server that is hanging behind the PBX, as in this example is, and as we've found in most PSAPs and that we've encountered. Okay, if this is the case of your PSAP, then you have to consider carefully what changes you will need in order to be able to support next generation eCall in your setup. Okay, then we have a second setup that we've encountered. That is PSAPs that have decided that they will completely shed their PRI ISDN, and the PBX that they have does support SIP, and they use SIP straight to the PBX. They have here a trunk SIP from the SBC receiving all the calls, and the eCall in turn, the eCall server in turn has a SIP trunk to receive the calls and receive the MSD, decode it, and then send the call back to an operator, all through SIP, through the PBX, through the internal PBX of the PSAP. One caveat on this setup. We've been advised by one of the contractors that has set up many PSAPs, that some PBXs, and we don't know exactly which ones or which versions of the software, but some PBXs actually receive the SIP call here, and when the SIP call emerges on the other side, the MSD is gone. That is, they do not conserve the whole SIP message. It purges some headers and some body parts of the message, and unfortunately, the MSD is purged. So even if you have a setup like this one, which would look like the right setup to use for a next generation eCall on a PSAP, you have to be careful and look if your PBX actually allows the MSD to go through. And you should test that before deploying next generation eCall, and make sure that you are receiving the SIP message on the other side with the MSD included. Okay. Well, an alternative to that setup would be this one, in which now the NGeCall communication does not go through the PBX, but rather directly from the SBC to the eCall server, to the eCall decoder. How do we do that? Well, essentially, as we saw at the beginning, eCall calls should be invites to a URN instead of a URI. Therefore, the SBC should select calls that are addressed to a service source eCall URN and send it to the eCall server directly, not through the PBX. And then the eCall, once the eCall server, once the MSD is recovered and decoded, can send the voice call straight to the PSAP agent through the PBX. One thing about this URN, in some cases, the call is not received through a URN, but a URI, that is essentially a phone number on SIP, on a SIP call to a phone number. In that case, the SBC has to be configured to discriminate the phone numbers associated with the eCall service, so those are directly routed to the eCall decoder. That puts a burden on the maintenance of the SBC, and it should be taken into account. And then there's an evolution of this, which is what happens if we also have a next generation 112 setup that is an ESINet. Well, in that case, it's essentially the same. We have the eCall server here servicing calls addressed to service source eCall, and then we would have an NG112 server servicing calls to a URN like source fire or source police or etc. Or ideally, one single element that can handle both. Like, for instance, the systems that a little bit of publicity, the systems that cells that cover both worlds on the same system, on the same software. Okay, and those are essentially the considerations that should be addressed by PSAPs on their setup on their side. And as you saw, it depends a lot on what the IMS provider, the MNO, is actually providing you, whether it's a URN in the call or URIs and so on. A quick reminder of the standards, of the upcoming standards and regulations. This is just a quick reminder of the dates for everything. Essentially, January 1st, 2025, that is 4 months ago, NGeCall can be implemented in new cars. That doesn't mean that manufacturers are actually putting cars with NGeCall on the street, but there could be some coming out already. January 1st, 2026, every new vehicle, every new vehicle should include, every new design should include an NGeCall IVS, no longer legacy IVS installed on new vehicles. And on January 1st, 2027, even older design vehicles have to change their IVS so it is NG capable. And on the PSAP side, PSAPs need to be updated in order to be able to handle NGeCall communications in January 1st, 2026. That is 8 months from now. So start making your plans. And don't forget that we in SECEL have solutions for all those problems. Speaking of SECEL solutions, a quick survey of our catalog. The NGeCall, this is the main product, the NGeCall server solution that serves as a decoder, is what we see here inside. It receives those SIP communications that include the MSD and voice communication. We act as a bridge. That is that voice, that communication. We separate, we capture the MSD, we decode it, and we send it to the PSAPs software, the CAD software. We use a REST API by sending a JSON object with all the information inside the MSD. And then as a bridge here, up here, we send the voice on a SIP channel through the PSAP. So the PSAP operator can receive the voice channel directly in its position, as if it were a voice call. Okay, our software, the early extract of the MSD, of course, because it's extracted from the invite message and the beginning, even before the call is completely established. We have categorization by URN, meaning that different URNs can be directed to different operator queues. If instead of URNs we receive URIs, there's phone numbers, we can also categorize by phone number, no problem. The decoding of MSDs, we support both MSD version 2 and version 3, even though NGeCall should be only version 3. We also support URN cap that I mentioned before, even though it's not mandatory, we support it. And our system is backward compatible, meaning that if you receive an inbound communication that is a legacy call communication, we will also handle it inside the same software platform. There's no need to have two different eCall systems. One solution handles everything. Okay, and the API availability, as I said, there's one part of the API to notify to the CAD the data contained in the MSD, and there's another bit so the CAD can ask for a resend of the MSD message, which is considered as part of the MSD protocol standard, the eCall protocol standard. This is what the configuration looks like. It's quite simple. It's what you receive, either the phone number in a URI or the URN, and where you are sending, to which queue you're sending that communication, and where you are notifying the information on the MSD. It's a web-based configuration. It's quite simple to use. Even though usually eCalls, once configured, they don't change much. We have a simple viewer in case you want to see the information contained on the MSDs received, on the different communications received. Normally, what you all that information, you will see it in your CAD once the integration is done. But in case your CAD is down, or in case you don't have the integration ready yet, or just for testing or simulation, we have a simple, again, web-based tool to allow you to see the different communications received by the eCall decoder and present it, as you can see, all the elements inside the MSD as text, plus using Google Maps, a positioning of the location received on the MSD. Then we have an interesting element, an IVS simulator. It's an application, well, an IVS simulator to test eCall PSAPs. The idea is that if you have an eCall on your PSAP and you want to make sure it's working, you need a tool to inject a call, an eCall call, so you can see that you receive the call, that you receive the MSD, you decode it properly, and you show the information properly. Well, we've developed an application for a mobile phone. Right now, it's available Android only. which has a graphical user interface that you can see at the bottom, in which you have every field of the MSD available, and you can fill that field with whichever value you want. That is, you're creating a synthetic MSD with all the information, including positioning that you see on the last picture. There's a Google Map position. You can point on a map where you want the position, or you can use the position of the mobile phone through its GPS system. And with that app, you just press the call button, and it will call what you see here, up here, the FES Sestel Simulator, which is a cloud-based solution. The app on the mobile will send that information to our simulator on the cloud, and that's our simulator will make either a phone call if we're simulating a legacy eCall environment, or will make a SIP call through the internet to the endpoint of our choosing, of our configuration. If it's a legacy call, it will use the modem to send the in-band information, the in-band MSD. And if it's a next generation eCall, it will send the MSD on the SIP invite headers as normally. That way, if you have a PSAP and you have an access point that can be accessed from our cloud, then you can test and send MSDs that you concoct on the application and see that you receive that information and it shows properly on your CAD or in whatever infrastructure you have to treat that information. This IVS simulator has been recently updated to support the full MSD version 3, including Euro and CAP additional data. This software simulator that we saw on the cloud can also be useful to test on-premise infrastructure, eCall infrastructure. And here we have a full eCall network, if you want. See, I'm including the IMS on the network operator, and ESINet in case there's one included, and the PSAP. Why? Because this IVS simulator that we have here on the left, it's the equivalent of what you saw on the cloud on the previous slide. And you also see here the application that is actually making a SIP call to this IVS simulator, and this IVS simulator can be configured so it can inject that call either inside the IMS to the ECSCF, which is the first point that treats an emergency call and that will handle an eCall call and route it all the way to a PSAP. That is if you're testing part of the IMS routing facilities, or you can point it to this second red circle you have here, and you can make a call straight to the BCF of an ESINet, in case you're testing the routing through the ESINet. Or if you're just testing your PSAP, this IVS simulator can be pointed straight to the third circle, which is the entry point of the PSAP, to make sure that your PSAP works properly with an NG IVS. This solution can be deployed on-premise. This is basically the same solution that we had here on the cloud. This would be an on-premise deployment of the same software. And then we're working on a hardware simulator, because there's one point that we were missing on the previous one. In this slide, you see the whole route of an IVS, of an NGeCall, starts with the IVS, travels through the 4G, 5G network as a voice over LTE call, and into the IMS, the ESINet, and the PSAP. Well, what we are working on right now is a solution that includes this part, because our software simulator only worked on the bottom part, no radio network, no voice over LTE network. And we're working on a solution to include this last piece here. Right now, it's a work in progress. We hope it's going to be ready by Q3 2025. And it's going to be an add-on to the simulator, the software simulator that we have for the cloud or on-premise, in the sense that we will use the same user interface on the mobile phone, that we will use a software IVS simulator to create and send the call in the proper format to the network, and so on. And then, well, this is a sum up of the different products that I've just talked to you about. The NGeCall high availability decoders that we saw. The upgrade from SES eCall to SES NGeCall licenses, that's because we've already sold some decoders that are capable of handling next generation eCall and have to be now licensed to actually handle them. So there's an upgrade for those. The viewer that we saw, the simulator app, and the hardware simulator that we also saw. And with that, I would also like to tell you that this is an ongoing work, because the final deployment is not yet ready. As you saw, the final deployment is for January 1st, 2026. And in the meantime, we are still working on the latest developments, on the latest additions to the NGeCall standard. In June, we have a plug test with all the vendors in Europe to test the interoperability of next generation IVS devices and our software. And we also participate in the standardizations committees in ETSI and in CEN, so we are aware of any last minute change in the standard, and we are working to make sure that we comply with everything up to the most current standard available. And that concludes my presentation, and I'm going to give back the microphone to Bertrand.
Thank
Go ahead,
you.
Bertrand.
Thank you a lot, Max. Great presentation. Let's now check the questions that we have, and we have two questions. One question is it possible to include or send the PDF flow? I think you have touched this during the presentation within the NGeCall station.
Yeah. Yes, yes, it is possible to include the PDF flow. Our product actually does include the PDF flow. The IVS simulator takes the position of the mobile phone that makes the call and includes that in the PDF flow of the call being made to the PSAP. So it's definitely possible. We do that already.
Okay, good. And other questions more on the let's say on the roadmap. What are the upcoming development that Sestel is planning for the IVS, meaning the radio simulator and NGeCall side?
Mostly, our next big step would be the radio simulator, the IVS hardware simulator that we're working on, and we hope to have it ready by Q3. So a full loop test can be done. In the meantime, as you saw, our IVS simulator allows you to do partial tests on the next generation eCall flow.
Okay, good. Okay, so for the group, if you have any if you have any additional questions, so we are unmuting the mic, so you can participate and join the conversation. Okay, I think that everything was clear, very clear, Max. Okay, so that brings to the end of today's session. Thank you all for joining. Just mention that the full recording will be shared via email, so we'll do it very shortly. And of course, if there is anything you want to know and to dive more in details, so don't hesitate to reach us at any time. And with that, we wish you a very good afternoon, the rest of the day, and look forward to keeping you in contact very soon. Bye-bye to all.
Thank you, everybody.